What if I told you that the ocean hides spinning vortexes so powerful they can swallow entire ships, and that these invisible monsters are actually controlling our planet's climate? Picture the ocean's surface on a calm day. It looks peaceful, almost still. But just beneath that glassy layer, forces are at work that make hurricanes look gentle. We are talking about whirlpools, massive, spinning columns of water that can stretch for miles and pull everything in their path into the abyss. For centuries, sailors told stories of these ocean monsters. They called them maelstroms, and they believed these whirlpools were gateways to the underworld. But what we've discovered in recent years is even more astonishing. These swirling giants aren't just destructive forces, they're actually essential to life on Earth. To understand why whirlpools matter, we need to look at what creates them. It starts with something you experience every time you pull the plug in your bathtub. Water naturally wants to spin when it's forced through a narrow opening or when different currents collide. Now imagine that same principle, but on a scale so massive it could fit multiple cities inside its spiral. That's exactly what happens where major ocean currents meet, or where water gets funneled between islands and continents. The most famous of these ocean monsters is the Moskstrømmen off the coast of Norway. For centuries, fishermen refused to sail near it. They said it could pull down whales and ships alike. And they weren't completely wrong. This whirlpool system generates currents so strong they can reach speeds of 20 miles per hour. But here's what's fascinating. Modern science has shown that even the Moskstrømmen isn't a bottomless pit. It's actually part of a much larger system of underwater rivers that circulate heat and nutrients around the globe. This is where the story gets really interesting. Because these whirlpools and currents aren't just local phenomena, they're part of the ocean's global conveyor belt. Warm water from the equator travels north, where it cools, sinks, and begins a journey that can last 1,000 years. Along the way, these currents create spinning eddies, smaller versions of the legendary maelstroms, that mix the ocean's layers and distribute heat. But what happens when this system gets disrupted? Scientists have found evidence that whirlpools can actually intensify during certain climate conditions. When ice melts rapidly, pouring fresh water into the ocean, it can alter the density patterns that drive these currents. The result? More frequent and more powerful whirlpools in unexpected places. Some researchers believe this might explain why certain shipping routes have become more dangerous in recent years. The real magic happens when we look at what these whirlpools carry with them. Every spinning vortex acts like a giant blender, mixing nutrients from the deep ocean with sunlight from the surface. This creates perfect conditions for phytoplankton, tiny organisms that form the base of the marine food web. Without these swirling mixes, much of the ocean would be a biological desert. The same currents that can sink ships also feed the fish that end up on our dinner plates. There's another layer to this story that few people consider. These ocean whirlpools don't just move water, they move heat. And the heat they carry determines everything from European winters to Caribbean hurricane seasons. When the Gulf Stream slows down or shifts position, it's often because of changes in these spinning systems. What looks like local weather is actually connected to underwater rivers and vortices thousands of miles away. Modern technology has given us new ways to study these phenomena. Satellites can detect subtle changes in sea level that reveal underwater whirlpools. Special buoys can be dropped directly into these spinning systems to measure their power. What we are learning is that the ocean is far more dynamic than we ever imagined, full of temporary whirlpools that form, travel hundreds of miles, and then dissolve back into the general current. The most surprising discovery: some of these whirlpools are actually protecting coastal ecosystems. When a large whirlpool forms near a coral reef, it can bring cooler water that prevents bleaching during heat waves. Other whirlpools create barriers that contain pollution spills or redirect harmful algal blooms. The very forces that seemed purely destructive are now being recognized as essential components of ocean health. So where does this leave us? The ocean's whirlpools are neither monsters nor miracles. They're natural processes operating on a scale we're only beginning to understand. They remind us that the ocean isn't just a flat surface we sail across. It's a three-dimensional world of flowing, spinning water that connects every continent and influences every climate. The next time you stand by the ocean, remember that beneath those waves are currents strong enough to circle the planet and whirlpools powerful enough to change weather patterns thousands of miles away. We've mapped only a fraction of these underwater rivers and spinning vortexes. Each discovery reminds us how much we still have to learn about the forces that truly rule our blue planet. What other ocean mysteries should we explore next? Comment below which natural phenomenon fascinates you most. Your suggestion could be our next deep dive into Nature Unlocked.